Hey guys, welcome to this session. Our topic is periodic classification. The past video we discussed about the various changing properties of the elements across the periods and groups in the periodic table. So today we move on to discuss about the electronic configuration to locate the positions of elements in the periodic table. This is the table which we are going to use, the modern periodic table of the first 20 elements. As we've noticed, we've been using this when we were discussing about the various changing properties of the elements across the groups and the periods. So today we'll see how we can just see locate the positions of the elements by these electronic configurations of the elements in the periodic table. Now, as you can see in this periodic table, there are groups and the periods. Groups, these are the uh, vertical columns. So in here, in this periodic table, there are 8 of them. Group 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 groups. And when we're talking about periods, there are uh, 4 periods in this modern periodic table of the first 20 elements. Uh, the periods are just the horizontal rows. As you can see here, this is the first period consisting of hydrogen and helium. The second period consisting of lithium to neon. The third period consists of this sodium to argon, and the last period consists of this potassium and the calcium. So we'll discuss this uh, simply in detail in the following. Now the modern periodic table, this is based on the electronic configurations of the elements. When you look at the table and when you start this table, the electronic configurations of the first 20 elements and where they are placed in the periodic table, you just notice the location and the position of the elements. Now the elements in the first group are the ones that are lithium, sodium, and potassium, having the one electron in the outermost shell. As you can see in our periodic table, these elements they are group D, but there are numbers written on them. Now these numbers are just describing the electronic configuration. Take an example. These the elements in the first group. When you take maybe lithium, there's 2, 1. It means the outermost shell it has 1. Then this sodium, the outermost shell also has 1, and this potassium also has 1. So in this group, 1, the outermost shell has 1 as the one of the elements that one of the electrons that are arranged in this electron configuration of these elements in group 1. So these lithium, sodium, potassium, they have 1 electron in the outermost shell. So these elements are in group 1, while the beryllium, magnesium, and calcium have 2 electrons in the outermost shell. And these elements are in the group 2. As you can see them are in group 2, beryllium, magnesium, and calcium, moving on to the third group until the last one. Now, this pattern continues to all the groups, 3, 4, and so on. Now, the group number in the periodic table is the same as the number of the electrons in the outermost shell. As we have noticed, when we're in group 1, the outermost shell consists of 1 electron. When we're in the second group, the outermost shell consists of 2 electrons, moving on until the last group. Now the halogens are the ones, the elements that are in group 7. Now as we move down each group, the number of shells increases by 1 at each step. Now each atom of an element has 1 complete shell than the one that is above it. Now, progressing from left to right across each period, the outer shell is being filled by 1 electron at each step. Now, certain electronic configurations are found to be more stable than the others. Take an example, the noble gases at the end of each period, they have full outer shells. So they have stable this duplet that is 2 electrons, and the octet, that is 8 electrons in their outermost shells. Now, this makes these elements more difficult to break up, and this fits well with the fact that they are so unreactive. Now, the outermost electrons of an atom are mainly responsible for the chemical properties of the element. Therefore, from this statement, you can see that the elements in the same group will have the same similar chemical properties due to that they have the same outermost electrons of the atom. So I hope it's clear, guys. Thank you for listening. We've discussed the electronic configurations of the elements simply on how to locate these elements within the periodic table. Thank you.